Good morning, students. Today is Wednesday, 22 July 2020. You are welcome in class physics of ninth O level. We have already started our chapter 12, and today our topic is work example on the page 236. Please, everybody, if you open your books, I'm going to read a statement. The statement is like here: optical fibers are widely used in telecommunication industry. You have to state three advantages of optical fiber. State advantages of optical fiber. Dictate you. Write, please, on your notebook. Optical fibers can carry much more information than copper wire. Optical fibers can carry much more information than copper wire. Second, optical fibers are cheaper than copper wire. And the third one, the loss of signal in optical fiber is less than in copper wire. Now, it was the first part. Now the figures. Look at the figure 12.48. There is a figure that optical fiber, a piece of optical fiber is shown in the figure. The thickness of optical fiber is 10.10 minus 4 meter, and minus 4 meter. This is the its diameter. Round shape, cross sectional area. Here I am going to draw the cross sectional face, and it's this diameter. If this diameter is given, that is of zero point 0.4 meter. Now, part B. I1 we have to find at point A, that is question mark. At point B, R2 is 19, and it's mean that the critical angle C at point B is equal to angle I2. Therefore, C critical angle is equal to angle I2. Now here sin C 1 over refractive index. This we are talking about point B. C is equal to sine inverse. This sine will be shifted on the right hand side. N is the refractive index of glass fibers. So when we solve it, 1 divided by 1.4 inverse of sine, we get 45 minus 6. So I2 at point B is equal to 45.6. Now I told you that I form one right angle triangle there, that now we have to find angle of incidence to I2, this one. We have to find angle R1. In the beginning, on the page I shown, this angle is 90. Now 90 minus angle I2. 90 minus angle I2, and this angle is also angle of critical. So 90 minus C, that is 44.4 degree. Now we have to find angle I, and we know using this formula we can find angle I1, refractive index, is equal to sine angle I1 divided by sine angle R1. This equation can be rearranged in the form sine angle I is equal to n sine angle R1. Again, look at this figure, this formula, n is equal to sine angle I divided by sine angle R1. This can be rearranged in this form: sine angle I1 in equal to n sine angle R1. R1 we have already found. Angle I1 is equal to, this sine will be shift on the right hand and it will become inverse of sine. Rest of the formula, n sine angle R2. Now angle I is equal to sine inverse n 1.4. This is given, that the refractive index of glass fiber. Now sine 44.4 degree. So first solve this, find the value of 44.4 sine, then multiply it by 1.4. Whatever the answer comes, you can multiply, you can get inverse of sine of this. So angle I is equal to 78.4 degree. Now we have to find its part C. Figure 12.49. Second figure 12.49. The rays that hit at A enter inside the glass fiber strand at point B. After that, total internal reflection happened, and this ray of light strike at Q. We have to find that what is the length of P and Q. So to find P Q, first we consider the triangle PYZ, this small triangle. This length is the half of total diameter. That was 1.4. We studied it. It is given. So this length P to Y is the half of diameter. That is 1.2. We will divide it by 2. So using trigonometric ratio, we will find x, then this x, this distance is equal. PZ has the same distance as that of the ZQ because it is half. Half is there and half is there. So it is sure that PZ and ZQ will be equal. So therefore, first of all, we find this x using trigonometric ratio. Sine angle 20. This R and this angle both are equal. In this triangle, this angle and this angle are equal. If this is 20, this will also be the 20. So sine angle 20 is equal to base over hypotenuse. Base over hypotenuse. Base is perpendicular. Perpendicular over hypotenuse. Perpendicular is d by 2. Perpendicular over hypotenuse. You can write here also that perpendicular over hypotenuse. So by using this trigonometric ratio, angle sine is equal to perpendicular over hypotenuse. So value of the perpendicular is d by 2 and the value of hypotenuse is x. We have supposed it. So if we want to find x, we will rearrange this equation and it will become x is equal to d over 2. It is same, and sine angle 20 will come here. Sine angle 20. Now d 10 minus 4 divided by 2 and sine angle 20. When we solve this whole set, we get 1.4 into 10 raised to power minus 4 meters. Now the PQ, P and Q, it is the 2 times of x. So 2x to multiply by the x, and we will get 2.92 into 10 raised to power minus 4 meters. Thank you boys. Today lecture little become longer as before. So I think that you may have understand the question. So if you have any problem, you can ask me on my personal WhatsApp or on phone, please. Thank you and God bless you. Have a nice day ahead. Stay blessed.